Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 14 in our incredible new tutorial series where you're learning how to make Python and Arduino work together. What I'm going to need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice. No sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to you guys who are helping me out over at Patreon. It is your support and your encouragement that keeps this great content coming. You guys that are not helping out yet, take a look down in the description. There is a link over to my Patreon account. Think about hopping on over there and hooking a brother up. But enough of this shameless self-promotion. Let's talk about what I am going to teach you today. And what I'm going to teach you is I am going to show you my solution to the homework assignment that I gave you in episode number 13. And what that homework assignment was to build a 3D simulation, a 3D model of a room with a little marble in it. And I will show you just as a reminder, Let's see if I can switch on over there. There it is. What your homework assignment was to create a 3D model with of a room with a marble in it using parameters. Okay. Now, how many of you guys were successful? If you were successful, leave a comment down below. I am legend. And if you were not successful, then leave a comment down below. I fold it up like a cheap Walmart lawn chair. Okay, so leave a comment. Also, I love it when you guys post your homework solutions to YouTube. Then down in your description, link back to this video. Then in my video here in the comment, leave a link over to your solution. And I look at every single one of those homework solutions that you guys post. And what I really love is you guys are developing a little bit of community. You're looking at each other's solutions and starting to comment on them. And man, subscribe to each other's channels and sort of let's get a little bit of a community going, you guys that are taking these classes and doing these homeworks, okay? But enough of this introductory banter. Let's jump in and let's talk about this. First of all, now you've already said I am legend or I folded up like a cheap Walmart lawn chair. And then also I want to see after you watch me do it, how many of you guys are still legend, okay? Because remember, we want to use as few of parameters as possible. And let's see if you guys sort of caught on to some things that would really, really make this a whole lot easier. All right. And so what I'm going to do is I'm going to have you guys fire up your most excellent Visual Studio Code. And then when you come over here, we will open up the File Explorer and remind you that I am working in the Pi Arduino folder, and you can come here and create a new program, and that new program we are going to call passdata-10.py, and the .py is kind of important, and boom, fresh new Python program, just waiting for you to write it. Okay, so we're going to build that simulation, and what are we going to do? We're going to start by defining our parameters. Well, we're going to start by importing VPython, I guess I should say. So we will come over here and we will say from VPython import star. Why do we do it that way? That way, every time we use a method in VPython, we don't have to keep saying VPython this, VPython that. Okay, now what are the parameters that we want to use? Now you might have been tempted to say something like floor width, floor depth, floor thickness, floor position X, floor position Y, floor position Z. You might have used, how many parameters did you guys use? How many parameters did you guys use on this? I'm going to guess that you probably used more than you needed, okay? Because really, there's four parameters that you need, okay? You don't need to give the size of the walls. You need to give the size of the room. So I want you to look at this, okay? I am not talking about walls here. I'm not thinking about walls. I'm thinking about this room. And what defines this room? It's a certain width, it is a certain depth, and it is a certain height. Okay? And once you define that, you don't go in and start defining separate parameters associated with the walls, because the properties of the walls are going to depend on those three alone and wall thickness. Okay, so my parameters are going to be room in the x direction, and I'm going to just say, let's just say that's 12 feet, and then room in the y direction, and I'm going to say that that's 10 feet, and then room in the z direction, I'm going to say that that is 16 feet. All right, now let me just say, why do I say x, y, and z instead of length, width, and height? Because I get in there, now which was the width and which was the height? Width and height are vague terms. They're not specific. They're ambiguous. Length, width, and height are ambiguous because which one goes where depends on kind of how you look at things. But x, y, and z are a coordinate axis, and there's no ambiguity, right? X is left and right. We have y going up and down, and z comes out of your screen. The positive z is out of your screen. Okay, x, y, and z. There's no ambiguity on what is what if we use these things. All right. Now I said we're also going to just need to say what is the wall thickness. I'm going to make them all the same, and I'm just going to say, let's say that's 0.5. That would be like 6 inches, since I'm kind of thinking in feet. All right, those are really the 4 parameters that you need. Now I'm going to throw in a couple of other ones just associated with like color and opacity and things like that. And so what I'm going to say is the wall color. The wall color is going to be a vector, and I'm just going to make it white, which would be 1, 1, 1. All right, and then I'm also going to have a wall opacity, because I think that things look more real if you don't make them just solid. So if it's like solid red, solid yellow, solid blue, it doesn't look very real. And so I like to give an opacity. And so I'm just going to say the wall opacity is 0.8. And that means it's almost solid, but there's just a slight bit of transparency to it. Now that ball was in that room, the front wall. That front wall, I want to be more transparent. I need the wall there, but I want to be able to see through it because we got to see what that ball's doing. And so I'm just going to say the front opacity is going to be equal to 0.1, so that you can kind of see it, but it'll be almost transparent. Now I will also have a marble radius, marble r, and I'll just say that marble is 0.5. That would be, again, like 6 inches. And then the ball color, I'll say that is going to be equal to a vector. And then that's 0, 0, 1 for a blue ball. All right, now all together, what did I do? 1, 2, 3, 4, 5, 6, 7, 8, 9 parameters. But really, as far as defining that room, there are 4 parameters and 4 parameters only. All right, and don't go be putting constants. Don't go be putting constants down in your model associated with where the ceiling and the floor and the walls are. Those positions should not have constants in them, all right? I hope you guys are seeing what I am getting at here, because I just know that as I teach this to students in real life, you know, in live classes, they never get this, and they always do this problem with way too many parameters. All right, so let's create our first object. That is going to be, let's call it the floor. Oops, floor turns green, which makes me think it might be a reserved word. I'll just say my floor, like that. So yeah, anytime I see it turn green, it might be I'm calling a method inside of VPython that I don't know about. So I'm going to change it to my floor. And what object would my floor be? My floor would be a box. All right. And then what is its size? Okay, what is the size of the floor? All right. We shouldn't go in and say floor X, floor Y, floor Z. We shouldn't have parameters on that because it depends on what? It depends on the size of the room. So the size is going to be vector. The size of the floor is going to be a vector. How big is the floor this way? It's not floor X. It's what? It's room X. The width of the room is the size of the floor. So the x value would simply be room x. All right. Now in the y direction, what is the y dimension of the floor? Not floor thickness, it's wall thickness, right? Because we're making everything that same thickness, right? And now, so we've got the x, we've got the y. How big is it in z? Well, it is room z, like that. Okay, room x, wall thickness, and room z. I hope that makes sense. Now we got to put it somewhere, so I got to give it a position. Okay, and that position is going to be equal to a vector, all right? And now where is it? Like here's the floor. Where is it in x? Well, it just sits where it is. It's just sitting there in x. You don't want to move it left and right. The floor just sits there. And so I'm going to leave it at 0. But now where is the floor in y? That is up and down. Well, I want the center of the room to be at the origin, so I want to move the floor down by half the height of the room. So I want the center of the room to be at the origin, so I need to move that floor down by half the height of the room. So how would I do that? So the position vector of the my floor is going to be 0 in x. I don't want to move it around, right? But it is going to be moved down minus by room y divided by 2. And that'll just drop it, all right? And now what is it going to be in z? We leave it alone. So it'll be 0, like that. Okay, now we just got to give it a color. So I'll say color is equal to wall color. I already set that up, okay? And then opacity, opacity is equal to wall opacity. I hope you guys can see that. You guys cannot see that, can you? Okay. This would be the only line of code that maybe you didn't see perfectly, so I'll just show it to you here to make sure you got that. So color is equal to wall color, and opacity is equal to wall opacity. And then what I can see is it doesn't recognize wall color, and so either I forgot to do that. Yeah, I forgot to do that. Oh, I made it a lowercase c, so I'll make that an uppercase c. And then we come back down here, and now wall color is happy. All right, so that is my floor. What would be the easiest one to do next? I just did the floor. What's almost the same as the floor? The ceiling. The ceiling is almost the same. So I say my ceiling is equal to, and then I'm just going to paste that line above it. Okay, like that. I'm going to paste that line above it. What is the only difference between the floor and the ceiling? The only difference between the floor and the ceiling, they're not a different size. They're in the same position in X. They're in the same position in Z. What is different between the floor and the ceiling? The floor we move down by half the height of the room. The ceiling we need to move up by half the height of the room. And so here on position where we said the floor was moved down by half the room height, here we need to make it go up by half as much. And so now if you go up by half the height and down by half the height, the distance between the floor and the ceiling is the height. Right? It's right. Okay. And that all looks good. And I'm going to go ahead and see if we can fire this thing up. Remember, we got to kind of keep it alive. So I'm just going to come down here and say while true, when it's true, true, true is always true. What do we do in the loop? We pass and do absolutely nothing. Okay, let's just run this and see if we got like a floor and a ceiling. Boom, we got a floor and a ceiling. And look at that. I did not define a parameter for floor size, ceiling size. I made them the dimension of the room. Man, that's so important. I just hope you understand what I'm trying to say. Okay, well, if I have my floor to my ceiling, I'm going to have a left wall, and left wall is going to be a box, and that box is going to have a size. Right, that box is going to have a size, and that size is going to be equal to a vector. Vector. All right. And now the left wall, how big is the left wall? How big is the left wall in X? I'll give you a hint. How big? How big? It is wall thickness. So this time wall thickness is not in the Y direction. Wall thickness is in the X direction. Man, I just hit my microphone. I hope that didn't make a big ugly noise. All right. Okay, so I have the wall thickness. Now I need, that was the X value. Now I need the Y value. What is the Y value going to be? It is going to be room Y. And then now what is the Z, the depth, going to be? It's going to be room Z, like that. It's just wall thickness moved over here to the X value. Does that make sense? Now we got to do the position. The position is going to be equal to vector. All right, and now where is the left wall? It's moved over in X. It is moved over in X. So the X is going to be, it's going to be moved over minus how much? Room X divided by 2. Okay, and now here we're not going to need to move it up and down, and we're not going to need to move it in and out, so it's going to be 0, 0. All right, so do you kind of see what happened here? This was moving the floor down and up, and now this is moving the wall left and right. Okay, and then we're just going to snag the rest of this here because the color and stuff will be the same, and paste it. All right. Now also we know that if I have a left wall, I'm going to need a what? A right wall, and that's going to be equal to, and it's going to be almost identical to this. Almost identical to this. So we will paste all this like that. Wow, I got a bunch of stuff that it doesn't like here. Left wall is equal to box, and size is equal to vector. Oh, I've got an extra closing parenthesis there, and that's making it all unhappy. Okay, I'm not sure why I've got that little squiggle there. I don't know if it's really a problem or not, but we can run it and see if it's a problem. Okay, so I should have a floor, a ceiling, a left wall, and a right wall. So let's see if that actually works. All right, let's see. I forgot a comma somewhere. Yep, I forgot a comma there. And when you copy and paste a lot, you copy and paste your errors. And so that's the problem. Okay. Ooh. Oh, yeah. I forgot I just copied and pasted. I copied and pasted left wall into right wall, and I forgot that the right wall, like if we move the left wall to the left by room X over 2, the right wall we need to move to the right, so that will not be positive there. That one. Okay. And let me make sure you see where that was. That was on right wall. That should be moved positive room X over 2. So we got 4 there. All right. Now what do I need? I need a back wall, and that's going to be equal to a box, and that box is going to have a size which is going to be equal to a vector. And now let's think about that size. This is the back wall. All right. What is its size going to be? Well, in the X direction, it is going to be room X. Okay, room X. This is the back wall, room X. What is the height going to be? Room Y. And then where does wall thickness come in? That's in the Z direction. That will be wall thickness is going to be in the Z direction. So now we have the size. Now where is the position? The position is going to be equal to a vector, and that vector is going to be, it's moved back. Okay, so in X, it's going to be 0. In Y, it's going to be 0. But in Z, it is moved back. So it's minus by what? Room Z divided by 2. Like that. Okay, and now let's snag this stuff here. I'm going to copy the comma this time, because the comma is kind of important. And then we'll set that, and that's the back wall. And so now I need a front wall. So I will just copy that. That was bad. I think I erased it. Okay, that's the back wall. And now this then, I just copied and pasted that same line of code. And so that's, I guess I'm not exactly sure what I just did. Oh, there it is. I pasted it at the end. Okay, so I have back wall. And then this one, I will make front wall. And the front wall will be the same size as the back wall, but instead of scooting it into the screen by room Z over 2, I'm going to scoot it out of the screen. So I'll make that positive. And this one I want to make a different opacity. And what did we say that was front opacity? Because I want to be able to see through this one. So here on this front wall, I will make front opacity. Okay, now we're almost there. What I will do now is we need to create our marble. Okay, we need to create our marble, and so our marble is going to be a sphere, and it's going to have a color is equal to, what did I call that color? Ball color. Okay, and then radius is equal to marble R, like that. So I think I should have a ball in a room at this point. I really do. I think I should have a ball in a room at this point. So let's see if this is going to work. Boom, ball in a room. And you see I can sort of see through these walls, and then the front wall is there, but it's almost transparent, so you can see the marble in there. Okay, now what your assignment is, and I'm going to show you a little bit about moving that ball around. Okay, I'm going to show you a little bit about moving that ball around. But what I'm going to do is I'm going to kind of show you how I move the ball, and then I'm going to give you an assignment to make that ball move all over the room. All right, but let me show you about how we would move that ball. Okay, let me show you how we would move that ball. And let me do a little bit of coding here. No, I don't want to. I want to kind of do it, make sure that you understand it on paper. And then after you understand it on paper, we will come back and start coding. And let's see if I can prop this thing up a little bit. Prop this thing up a little bit. Get everything square again. Okay, so all right, now I think I'll come over here. All right, so what I want that ball to do, and did I actually have it over here? I think I had it going, didn't I? Okay, what I had going earlier was I had it going bouncing back and forth. Do you remember? And so what I want that ball to do, you're not able to see that, so I'll put it over here. I want that ball to go over, and as soon as the ball hits the wall, I want it to bounce back. And then when the ball hits this wall, I want it to be bouncing left and right, hitting the wall and coming back. Now, guys, again, I tell you these things because I taught for many years live students in the classroom, and they would just struggle with this, why they would jump in and start coding before they really defined it. All right, and so this is, I'm going to kind of try to draw it here, and I am not going to draw nice things. I'm just going to kind of freehand it. And so what I'm going to draw over here is, this is going to kind of be the left wall. All right, and then what I'm going to draw over here, this is going to be the right wall. Now we have to understand, then remember we put the origin here. So when do we want to bounce? We want to bounce, we want to change direction. That was not good. We want to change direction when? We want to change direction when the right edge of the ball touches the left edge of the right wall. So what I'm saying is, when this touches right here, if it's coming this way, then it touches and we want it to go back the other way. So what we've got to do is, we've got to figure out where the right edge of the ball is and where the left edge of the right wall is. Now, let's just see if we can kind of draw this down here. This is the ball, and then this is the wall. So this is here, that point right there, this point right there, that is the left edge of the right wall. And excuse me, where is that? Where is that? Well, this position right here, the center of the wall, we moved it over by how much? By room x divided by 2. So this position right here is room x divided by 2. But we don't want that. We want this position. That is room x divided by 2 minus wall thickness divided by 2. Does that make sense? That is this point. Now, what is this point? This point would be the ball X position, wherever that is. The ball X position would be right here, and then we would add to that the ball radius. And you can't see that. So we would add to that, we would take the ball position in X and we would add to it the radius. And so this is the right edge of the ball, and this is the left edge of the wall. So in our if statements, I want to compare these two. And when this gets to this position, then I've got to change the direction. Okay, now let me do one more here for you, and then we'll jump in and start coding. But I really want you to understand these things, so I am going to go ahead and clear this. And now we've got to think about the other case that we care about. The other case that we care about is when what? The left edge of the ball is at the right edge of the left wall. Okay, and so let's try to kind of do that. So the left edge of the ball, that's right here, the left edge of the ball, and we're comparing that to the right edge of the left wall. This is the left wall. This is the right edge of the left wall. And so this is the thing that we care about. Has this gotten here? And if it has gotten here, then we want to change directions. All right. And we have to remember again that this is the overall position of the left wall, and this is the overall position of the left wall plus half the wall thickness. So you got to keep track of the radius, because the way people usually do this, they just bounce when the center of the ball is at the wall. Well, here is the wall, here's the center of the ball, and so when they run it, it typically doesn't bounce until the ball has kind of gone into the wall, if that makes sense. But we don't want to bounce here. We want to bounce here, so we've got to keep track of the thickness of the wall, and we got to keep track of the radius of the ball. Oh my goodness, I've talked too much, and probably half of you guys have left already. And so let me come back over here. That was kind of strange. It's like we've lost our sketch pad for some reason there. But that's okay, because we're going to come over here and we're going to start coding. I just wonder, why did that sketch pad die? Makes me say, oh, okay, it's working. Even though you couldn't see it, just bothered me that it disappeared. Okay, so let's get me back to my more appropriate size. And now we're going to go in and we're going to make that ball move back and forth. Well, now I'm going to need a new parameter. Okay, I've got the marble radius and I've got the ball color. I really should have called it a ball, or I should have either called it a ball or a marble. I shouldn't have called it both, but so be it. Okay, now we've come in and we've gotten the ball set up, and we've come in and we've got the, what else have we got set up here? We've got the room set up. And so now what we need to do is, got a little bit of a bug on my keyboard there. Okay, now what I've got to do is I have got to come in and start thinking about moving this. So I created the marble, and now I need to give it a marble X position. And I'll just start the marble X position at 0. So that's where the ball is in X. And then each time I want to move that ball by a small amount. And so that is going to be delta X, and that's equal to, I'm just going to say 0.1. Okay, so I'm going to say that each time through the loop, I'm going to move that ball in an increment of 0.1. All right. Now, this is what I'm going to do down here. I'm going to, instead of saying pass here, all right, instead of saying pass here, I better give it a rate so it doesn't run too fast. I'm just going to say rate 20, so that's going to kind of go through the loop 20 times a second. And now what do I need to do? Well, I need to move the marble. And how do I need to move the marble? I need to say marble X is equal to marble X plus delta X. And so that increments marble X. Well, then what do I want to do? I want to apply that. So now my marble dot pos for position is going to be equal to the vector. It's going to be equal to the vector. And what is the vector? Well, what am I changing? I'm changing the X position. So it's going to be marble X. Am I changing the Y position? In this case, no. Hint, hint, I said in this case, no. Maybe in the homework, you'll have to think about this. And then am I changing the Z? No, I'm not changing the Z, so it will stay there. So I'm updating it. So every time through the loop, it's just going to increase the X value. So let's just see if the ball moves. Let's just see what happens here, right? Probably, I hope you can say what's going to happen. Okay, but let's look at it and see it happen. Okay, there it goes. It's going. And then we have a what? We have a jailbreak. It just keeps going. Why? Because we didn't check that. We didn't check that condition of whether we need to change direction. So we need to go in and do that. So after we increment the ball position, or the marble position, we need to come in and we need to say if marble x. And remember, what I want to see is I want to see if the edge of the ball is touching the edge of the wall. And I'm going to start on my right. Okay, I'm going to start on my right. So I'm going to say if marble x plus marble radius, so that is the x position of the marble plus the radius, that is what? Marble x plus marble r is what? It is the right edge of the marble. And if that has become greater than the left edge of the wall, well, what is the left edge of the wall? Well, it is the room x divided by 2, right, because that's over there. But now that room x divided by 2, that's the position of the center of the wall, but we want the left side of the right wall. And so what do we have to do? We have to subtract wall thickness divided by 2. Now, if it doesn't make sense what I just said, back up and look at that picture, because this is exactly what we just defined. So if that is the case, what do we want to do? Well, the delta, the amount that we're moving it, the delta x needs to be delta x times minus 1. So if it's moving in the positive direction, it'll flip it and move it in the negative direction. If it's moving in the negative direction, you multiply by minus 1, it'll flip it and make it go positive. So this will change direction, okay? But we not only want to bounce if it's in that condition, we also want to bounce, and I can do that by making this an or. The other condition where we would want to bounce is if the marble x minus the marble r. Now, what is that? Marble x minus marble r, that is the left edge of the marble. And if that is less than, that means you've moved too far to the left. If that is less than what? The right position of the left wall, the right edge of the left wall. And that would be minus room x, right? Because we moved it, the left wall, we moved to the left by room x divided by 2, okay? Room x divided by 2, but now we got to adjust for the wall thickness, so plus half the wall thickness. So plus wall t divided by 2. Okay, those are the two conditions that we change direction. All right. I might have made a mistake in there, but let's just run this. My logic is correct. I just don't know if I missed a sign in there somewhere. Okay, we're coming up to the wall. We didn't bounce. What did I do wrong? Why did that not bounce? Why did that not bounce? Let's come back over here and let's see what's going. Okay, it could be that I said if it's greater than, it could be that it just has gotten stuck there, and I forgot that if you're inside of this if statement and you change the direction, then right after you change that direction, you do need to apply that. So I'm going to say marble x is equal to marble x plus delta x. Now why? Because let's say I'm coming towards the wall and then I go into the wall a little bit, I change direction, well, I got to back it back out with that new direction. So I think you've got to have this in here. I really hope this works. All right, let's try it again. Oh, what happened there? Let's try it again. I might actually have an error in here. I thought I saw an error. Okay, is it going to stick? Yes, it's going to stick. Right exactly on the edge, but I think I got an error. And so let's see what it didn't like. It might have been in that, it's going to be in that if statement or that or statement. So let's see. Wow. It's like every time through the loop it was getting that error. And so let's see, what does it not like about my if statement? It's got to be in there in that if statement. If marble x plus marble or. Do you guys see the mistake? See, the thing is, I am not seeing... Oh, is that right? Delta X. How did I mess up my delta X? Okay, let's make it all upper. So this is going to be delta X. Somehow I started making little delta X's and big delta X's. Delta X. And then delta X, delta X, delta X, delta X, all uppercase. Okay, I think it should run this time. I think that was what was causing the error. I certainly hope so. I'm just not sure why it didn't underline that. Okay, let's hope. Let's hope. Boom. Ooh, but that was kind of crazy, wasn't it? Now that is crazy. Okay, that must be inside that if statement, that crazy thing I did. I must have written that one wrong. Marble X is equal to marble X is equal to delta X. That's kind of crazy. And so we will say marble X is equal to marble X plus delta X. Boy, we had like about a minute and a half of some really bad coding and not paying attention stuff going on. So we're going to kill that. I think it's going to run this time. Okay, hoping for a bounce. Boom! Did you see that? Okay, hold your breath. Shazam! Did you see that? Okay, so you see this thing is bouncing back and forth in X. Okay, and when it hits a wall, it bounces off. Now, what is your assignment? I want it not to just be moving left and right. I want it to also have a component where it's going up and down, and then it's going to have to bounce off the top wall and the right wall and the floor and the left wall, where you're doing what I've done in one dimension, but now you're going to be going in X and Y and Z. So I just want that thing moving around smoothly, bouncing off the top, the bottom, the left, the right, the front, the back. I'll give you a hint. I did the hard work for you. But now you're going to have to come back to Sketchpad, and you really need to, again, the secret here is, the secret is that you get your parameters done in your picture. You get your parameters done in your picture, all right? And so, like, what are things that you're going to have to worry about now? You're going to have to worry about things like the top of the ball and comparing that to the bottom of the ceiling. Okay, and you're going to have to worry about things like the bottom of the ball and the top of the floor. All right, so sort of what I did, left wall, right wall, you're going to have to do that. Ceiling, floor, front wall, back wall. Does that make sense? But I've really, man, guys, I promise you, I have done the hard part for you, and you should be able to figure the rest of this out. Okay. Where is all this craziness going? We're heading towards a game. Okay, we are heading towards a game, and in that game we will be coming in, and we will be hooking a joystick up. We will be hooking a joystick up to the Arduino, and then we're going to get a little gameplay going. This thing is going to become animated based on what is going on with the... Why did I put that LED up there? That was not the shot I wanted. That LED was from an old lesson. We're going to animate this thing with the joystick, and we're going to turn it into a game. All right. Now, why is this important? Because, well, we're learning how to do things graphically in Python, and at the same time passing data back and forth from Arduino. And then, even maybe more important than that, the things that we're designing about 3D objects, that's going to lay the groundwork in the foundation for our CAD, our 3D CAD and 3D printing class that will be coming up shortly. Okay, guys, I really hope... Oh, and when you do your homework solution, make sure that you post your homework solution to YouTube. Leave a link in a comment down below over to your solution, and then in your solution video in the description, link back over here. And then look in the comments and go look at other people's solutions, and let's see how different people are doing this. And really, guys, I look at every one of the homework solutions that you guys post on YouTube. All right, if you like this video, make sure you give us a thumbs up. Make sure that you leave a comment down below. Both those things help me with the old YouTube juice. And when you do that, more YouTube will offer this video to more and more people. And that's really important because we need more people coding and doing engineering and fewer people sitting around watching silly cat videos. This is Paul McWhorter with TopTechBoy.com coming to you today from the banks of the mighty River Nile. I will talk to you guys later.